Hello and welcome to my channel. If you've been here before, welcome back. My name is Alfonso Peluso and I'm a Studio Associate Professor in the College of Architecture at IIT, the home of the legendary Mies van der Rohe, and I'm adjunct faculty at Columbia College in Chicago in the Interior Architecture program. Shout out to all my students. I hope everyone is doing great today. I'm doing great. It is spring in Chicago, and today it is about 50 degrees and sunny, so I'm pretty excited about spring being here. Alright, today we're going to look at a plugin for Grasshopper called Chromodorus. What are some of the things that you can do with Chromodorus? Well, I have this sample file on the left, and I have some number sliders here. So I'm going to change the amount of elements that I have. So you see that happening there. I'm also going to change the seed of those elements. So the form is changing based on a seed of points. I can also change how the smoothing is being applied. So you can see some differences in smoothing here. It's getting a little bit thinner and thicker here. And here is the amount of smoothing. So I can go where I have almost no smoothing and it gets very pixelated or voxelated, as we're going to talk about today, or I can make that much smoother. So that's just a little bit of what we're going to cover today. There's going to be a lot more to it. Alright, before we jump into it, if you have not subscribed to my channel, what are you waiting for? Go ahead, search me up on YouTube and hit the subscribe button. I am 100 followers away from 8,000. So 8,000 I hope is going to come pretty soon. 8,000 subscribers, that's going to be great. So go ahead and click on the subscribe button, click on the bell to receive all the notifications. There is something here for everyone. If you're working on computational design, I have a video for you. Also, follow me on Instagram. I've been growing this community and I've been posting a lot of my students' work so you can see what my students are producing. I'm very proud of what my students produce, so I like to show it off so you can see what we're up to both at IIT and Columbia College. Alright, so Chromodorus. What is Chromodorus? So I had to Google that one, and turns out it's a very colorful sea slug. So here's some images of this very colorful sea slug. So where do you get Chromodorus? Well, you go to Food for Rhino and you search Chromodorus, or you can use this web link, foodforrhino.com/app/Chromodorus. Alright, well, let's jump into it. We'll come back to some of these definitions in a little while. Alright. Just get that file out of the way for us. So here is our outline. We'll be looking at sample voxels, build isosurface, quick smooth, draft angle, sample voxels, close voxel data, and our bonus will be charges. Alright, so we need some basic information to start our file. How about units? How about size? So let's go to File, New, and we will work in small objects inches. So I will say unit size is really important with this plugin. So a lot of these number sliders that I'm working with, they're really based on unit size. So keep that in mind if you're working with Chromodorus. Alright, I'm going to change my grid, make it a little easier on the eyes. So I'm going to type in DOC, enter. And I'm going to change the grid. I'm going to make a grid count of 24. I'll make my minor grid lines every 12 inches. Major grid lines can be every 4 minor, so every 4 feet. And I'll set my snap spacing to 12. Okay. Alright, so the scale that I'm going to work at is about 16 inches tall tall. So that's what I'm going to start with. Okay, so relatively small size. So I'm going to go ahead and start out by creating a box. And there's different types of boxes you can create in Grasshopper. I'm going to start with a center box. Okay, so it puts a little box at 0, 0, 0. That's the base. I can change the size of this box. So I'm going to make it 6.000. So I want to have some decimal places so that I can have some flexibility in the size that I make this box. Okay, so a center box, what it does is it expands on both the negative x and the positive x. So what you're looking at right now is actually a 12-inch long box. So it's actually 12 in the x. And I'll copy and paste that, and I'll plug that into the y, and I'll just change the size a little bit. And for the z, I'm going to want to make sure that it can be 16 inches tall, so it's going to have to be at least 8. Okay. So there's my 6 by roughly 5, or actually 12 by roughly 10 by 16 inches tall. That's the box. I want the box to start at 0, 0, 0, so I want to shift it up. So I'm going to add a unit z, a z vector, and I'm going to plug that into base. And as long as I keep my z plugged in, it's going to raise it up half the height. So it's going to put it right at 0. Alright, so there's my box. Okay, fantastic. So now what I'm going to do is I'm going to generate some points. So I'm going to use Populate 3D. Okay, we'll come back and talk about Populate Geometry because that's another real good one. So Populate 3D will generate points within a region. In this case, my box, my center box that we just made, is going to be my region. So I'll go ahead and plug that in, and I have a whole bunch of points in here. And I can change the amount of points that I have, so that's going to be the count. So I'm going to plug in 100. So that's going to be my maximum number of points. I can lower that or bring it all the way up to 100. I have a seed which shuffles around where the point locations are. So I'm going to type in 50. That's going to give me a number slider between 0 and 100. And I can shuffle those points around. Okay. Alright, so we have our points. Now, the more points you have, so I'm going to start some scribbles here, some notes for us. Okay. More points equals slower computation. Okay, so something to keep in mind when you're working with Chromodorus. Right, we're pretty good at getting Grasshopper to crash, so just to avoid that happening, make sure that you're always saving often. Okay, so now we have another capsule that we're going to use to create lines that connect all these points together. So that's going to be called proximity. Let's try to get it spelled right. Proximity 3D. And I'm going to plug those points in. And you see it's connecting all those points with a series of lines, and you get this really cool wireframe structure. I'm going to hide capsules as I go, so maybe it's not, well, yeah, why not? Why not right now? So I'm going to take these and right click and turn the preview off. Okay, so here's my wireframe. So a couple things about Proximity 3D. This is a really cool capsule. So one, there's a group, maximum number of closest points to find. So remember, this is all starting with my points. So it's all starting here with points. So this group is going to be how many points do you want to find that are close by. So right now it's finding 5 points that are close by. Okay, so I always like to start with a number slider at what the default was. So when I hovered over it, it was 5. And then I can lower this down. So less points equals less lines. More points equals more lines. Alright, so I'll keep it around 5. Okay, so we have a minimum radius and a maximum radius. And nothing is plugged into those. So this is just another way that it's searching for proximity. I can do a minimum radius and a maximum radius. So let's take a look at, not sure what to plug in because there's no default, but let's start with 1.555. So I'll plug that in. And it looks like as I get into the higher values, I'm getting more lines, okay, because it's finding more points to connect to. So this is another way you can control how many points to connect to. And then that's the minimum radius, and then there's the maximum radius. So I'm going to go a little higher with this one. I'm going to try 12.555. That's just going to give me a number slider that's greater than 10. Okay, so that's my max radius. So let's see what happens here. Okay, so my minimum radius has to be pretty low for this to start to work. Alright, so just some other ways that you can be flexible inside of Grasshopper. Okay, I want to start with less lines right now, especially when we're just taking a look at the plugin. So that looks pretty good, not too bad. Okay, so that's our proximity 3D. So that's just setting something up really basic. We haven't done anything in Chromodoris. That's just setting something up really basic in Grasshopper. Okay, so let's look at the Chromodorus plugin. So I got a bunch of C's up here. So there it is. That's my C. That's my Chromodorus. And I'm going to start by sampling voxels, or creating a bunch of voxels. So sample voxels is where I'm going to start. And you're going to see that it requires some input. At the very minimum, it requires points. So I'm just hovering over the little bubble in the upper right. At the very minimum, it requires points. It requires a voxel size and an effective range. So those three things are the minimum: points, voxel size, effective range. Okay, let's start with points. We don't have any points yet. So how do we get points? Well, we're going to use divide, and I'm going to use divide lengths. Now you might have more than one divide lengths depending on your plugins, but I'm going to use this icon here, divide length, because there is another one down here. So I'm going to make sure I use this one. Okay. And I'm going to plug my links. So links is another word for lines or elements. So I'm going to plug my links in. Now, when you're using Chromodoris, anywhere you see a data tree, the dashed wires, which arrange things in a list of lists, anywhere you see that, you can flatten that down. Okay, so I'm going to flatten this down. And I'm going to plug my, now it needs, there's a bubble here, so it wants the input length. So the length that defines the distance between my points. The length that defines the distance between my points. So I'm going to start with a number slider at 1.000. Okay, and I'm going to go ahead and plug that in, and now you see all those points, and as I lower this down, the points get closer together. Okay, so those are my points. Now I'm going to plug that into my sample voxels. Okay, so I'm going to plug that in. Okay, again, I'm seeing a data tree structure there, so I'm going to want to flatten that. So I go ahead and flatten that. Okay. Now, the other two things it was looking for was effective range and density sampling. Okay. Let's talk a little bit about this. I'm sorry, it wasn't looking for density sampling. It was looking for voxel size and effective range. Okay, so what's a voxel? All right, so if we Google that, if we Google what a voxel is, I found this image. I thought that this was sometimes an image is worth 1,000 words. So here on the left is a very smooth model. Looks like a little gamer model there. But on the right is the Minecraft version of it. Okay, so Minecraft, that's one way we can talk about voxels these days. So voxel is another way to think about three-dimensional resolution. Okay, so 3D resolution is what voxels are. So we're going to talk about changing the voxel size and then the effective range of the voxels. And then we're going to be smoothing it like this, the way this gamer is on the left. Okay. So let's look at this voxel size. All right, so we're going to plug in, I'm going to plug in 0.800. Okay, that's going to be my voxel size. And I'm gonna label this voxel size. So I'm just right-clicking and I'm gonna call it voxel size. And then I'm gonna define that. Okay, I'm gonna add a scribble. Okay, so we're gonna say voxel size equal mesh, because we're working with meshes. If I haven't mentioned that, we are working with meshes. So mesh face size. Okay, voxel size equals mesh face size. So the smaller the value, the smaller the faces, the slower the computation time. So that's something to think about. Okay, so that's voxel size. Give ourselves some room here. We also have the effective range. So I'm going to make a number slider for this. So I'm going to make this, I'm going to start with, now having these number sliders set to 0 can be problematic because that's a good way to crash Grasshopper. So I'm going to make this 0.5 less than 5.000. And we'll talk more about what this means. And this one I'm going to change the value so it doesn't go down to 0. I'm going to try like 0.002. Okay, so this is my effective range. Okay, and I'm going to crank that up a little bit, or quite a bit. All right, that's my effective range. Okay, now it's created this box. Okay, we'll get back to talking about this box in a second. Let's add a scribble here. Okay, effective range. Okay. Effective range equals how many voxels are affected from each point. Okay, it's a little longer than I want it to be, but it's as short as I can make it. How many voxels are affected from each point? So it's like a search range. Okay, it's not it's it it doesn't change it doesn't make the mesh thicker or thinner, so I want us to realize that. But it's a search range of how many voxels are affected from each point. Okay, so how many of those little three-dimensional pixels are affected. And once we start moving the number slider around, we'll get a better understanding of it. Okay, here's you see the box in 3D. Okay, so you see that changing, but again, it's not, I don't want you to think of it necessarily as the size of the box, because when I lower this value down, it's not getting like really small. Okay, let's start with 0.8. But the effective range does seem to change the size of that box. Okay, that's our sample voxels. Next we're going to look at building an isosurface. So build isosurface is our next capsule. So I'm going to plug box into box. I'm going to plug voxel data into voxel data. Okay, now we're going to have to talk about what an isosurface is. So let's go over to Google here and let's look at isosurface. So I liked this definition the most from what I saw. It seemed the easiest to comprehend. An isosurface is a 3D surface representation of points with equal values in 3D data distribution. Is the 3D equivalent of a contour line. Okay, so when we go to images, we see a lot of different images. Okay, and I think, you know, maybe something like this starts to make some more sense. So it's three-dimensional contour lines from a point. Okay, and those can be based on a lot of things of visualizations. They can be based on heat or weight or velocity. So let's look at it specifically in Chromodorus and see if we can get a better understanding of it. It's almost like, one way to describe it would be, at every point, if you made a sphere, and as those spheres started to intersect each other, so if you could imagine this cube filled with a bunch of points, you put a sphere on every single point, and as those spheres start to intersect each other, they join and they merge and they union together. So that's what we're looking at in an image like this. Okay. Alright, so let's see if we can produce some of this and make some of this happen. So sample value. So let's look at the sample value. So what I'm going to say about this one is that it inversely changes the thickness of the mesh until the mesh breaks open. So that's a pretty long one, but we'll add a scribble here. So this inversely, so what does that mean? So I'm talking about changes the thickness. So the lower the value, the thicker the mesh. So inversely changes the thickness of the mesh until it breaks open. Okay, so I'm going to say lower values equal thicker mesh. Okay, so that's my definition there. What to start with, that's always the tricky thing. And again, these are based on units. So if you're working with smaller or larger objects, that's going to matter for a lot of these number sliders. So keep that in mind. Okay, so my sample value, I'm going to set that to, I'm going to make a number slider that's from 0 or 0.003 to, I'll make it up to 2.00. Okay, and I'm going to plug that in. I'm going to make this bigger this sample value, because it's smaller is thicker. So right about here, see what happens. Okay, so we have something happening there. So we're gonna hide a bunch of these capsules. Okay, so we have something happening there. So what's happening? Well, that's the goal, to try to see what's happening. So I'm going to use a custom preview. Okay, so we can see what's happening there, and I'm going to turn this one off. Okay, so we see something happening there. Pretty cool, pretty awesome. I'm always saving, especially when you're working with complex meshes like we are. Okay, if you can't see the meshes, if you can't see those mesh lines, under Display in Grasshopper, under Display, Preview Mesh Edges, or Control M. Control M is the shortcut to turn those mesh lines on. Control M. Okay, so we see those mesh edges. Alright, so I want to control the thickness of that mesh. So I'm going to take this down, and it's getting thicker. So is that what we said? Lower values equals thicker mesh. Okay, lower values equals thicker mesh. I'm going to take it up higher. Okay, and they're getting thinner. Okay, so we have some other adjustments that we want to make. Okay, so let's take a look back at the voxel size and see how this affects it. So voxel size equals mesh face size. So those are the triangles, the faces, how many triangles we're going to have. This one is one I always want to be careful with. Okay, as I go higher, as I go lower. Okay, those triangles are now getting, they didn't look like they were getting smaller, but as I go smaller, they're getting smaller. So I'm going to look at my effective range and see what happens there. Okay, that's also adjusting how many voxels are affected at each point. Okay, so I want to make this a little bit thinner. So I can do this a few ways. One way is I can add more points. I've already cranked that up to 100. I could add more points there. Another way is I can keep working with the voxel size and the effective range and the sample values. I can keep working with this. So let's go a little bit higher on that sample value. Let's start with that. Okay, so the range of this, I'm going to make this maximum, I'm going to make it maximum 5. Okay, and see what happens there. Okay, so you see that. And then it starts to break. So that's what I said. Inversely changes the thickness of the mesh until it breaks open. Lower values equals thicker mesh. So at some point, it starts to break. Alright, so let's look at this in color like I showed in the demonstration image. So that's going to be looking at under, well, we haven't smoothed it yet. Okay, so that's going to help too. So let's look at smoothing this mesh. Alright, so let's go ahead and do that. I'm going to add a quick smooth. Okay, and I'm going to plug my custom preview into that. Alright, so we're getting this smoother mesh. Okay, now the custom preview isn't working as well as I want it to. So we're going to add, and we'll talk about these a little bit more. We're going to add, under display, we're going to add a draft angle. So I'll go ahead and plug draft angle in. Okay, now it wants a minimum draft and a maximum draft. I've messed around with this a whole lot trying to, figure out a really good way to explain it. The best colors that I've gotten are from a minimum draft of -45. So I can slide this all the way down. and a maximum draft angle of 45. Okay, and there we go. We get some really cool coloring there. And the best explanation I can figure out right now is that the bottom surfaces are red, the top surfaces are blue, and green is in between. And I don't know if our view display doesn't really help too much with that. Okay, a couple of things about the smoothing. We have the amount of iterations. So let me hide this. This helps if I hide this actually. Okay, if I'm just seeing the draft angle, that helps quite a bit. It's a lot brighter. So we have the iterations, okay, the number of smoothing iterations. Right now it's 1, and then the step is the multiplier of that. Okay, so let's look at that. So iterations, let's type in 11, something higher than 10. Okay, so now you're seeing some smoothing. So that helped make it thinner. Okay, that's why I didn't want to go to adding more points right away, because I knew that I had some smoothing operations that I could apply. So we worked a little bit with the sample value, and now we're working with the meshing iterations to make that smoother instead of adding more points. Because more points equals slower computation time. Okay. Then there was also the step, and step can only be between 0 and 1. So I'm going to put in 0.555. Okay. So that multiplies the smoothing. So if it was a certain thinness, it gets even thinner, it multiplies it. And then this is the number of iterations, and it goes back to almost voxel to something much smoother. Pretty awesome. Okay, so we'll add a little scribble here, a couple scribbles. So this is my smooth step. So this multiplies smoothing. And this is my iterations, my smooth iterations. And let's give some space here. Okay, I'll add another scribble. Okay, and this is number of smoothing iterations. That's pretty self-explanatory, but number of smoothing iterations equals smoother mesh. And so far everything that we're doing is pretty quick. Like it's pretty fast in the computer. It's pretty fast in Grasshopper to do this. Okay, so what's important for me when I'm doing this is I want to make sure that this is a closed mesh, a 3D printable mesh. Okay, so that's really important for me. So if you do see some openings in your mesh, you're gonna wanna adjust. I found that it's helpful to be adjusting the sample values. If you see some holes in your mesh, you can work on closing those holes up by working on this sample value. Change that. Okay, so my goal is 3D printing. Okay, I want to be able to 3D print these meshes. And right now I'm working with my generative design class, and we are focusing on prosthetics, and we are printing prosthetics. So this is about the scale that we're working at. So I want to make sure that this is a printable mesh. So I'm going to go ahead and I'm going to bake this. I'm going to right click and bake this. I'm going to right click on that, go ahead and bake it. I'm going to bake it to the default layer. I'm going to save this and just close Grasshopper just so I can see this wonderful mesh in Rhino. And I'm going to go ahead and I'm going to change that. So I'm going to change that to be shaded. And you see the colors come over, which is really great. And this is something that I could 3D print. If I exported this as a .vrml file, I could 3D print this in color, which is great. Okay, so I'm going to select it and I'm going to check the mesh. Okay, so everything looks really good here. Mesh does not have any degenerate faces, n-gons. Really what I'm really interested in is that it doesn't have any naked edges. Okay, so this does not have any naked edges. If it had some naked edges, again, I would go back and I would start to change that sample value for the build isosurface surface capsule. So that's, if I bring Grasshopper back up, that's this one, sample value. I would change that. If it had some naked edges, that means it has some holes in it somewhere. Okay. So one thing you might have noticed that it says it has 2 disjoint pieces. Okay, so I found that if you explode it, so if I take this and I explode it, it says exploded a polygon into 2 meshes. So I tried clicking around to find where the 2 meshes are and I couldn't find it. But if I click on this obvious large mesh that's here, if I click on that and then I just type in hide, okay, it's showing me another mesh. Actually, this is the Grasshopper mesh, so I got to be careful about that. There goes my dog. My wonderful dog Rita sees a couple other dogs out there. Okay, so I'm going to show this mesh again. Okay, so I'm going to select it and hide. And I don't see anything there. So I'm just going to type in SEL mesh. And it says one mesh added to selection. And I'm just going to go ahead and delete it. And I'm going to show my original mesh. And I can select this and I can type in check. Okay. So that's a good mesh. Doesn't have any naked edges. That thing is ready for 3D printing. Now, you know, things like how thin some of the areas are could be challenging, so you'd want to be measuring that to make sure things are thick enough, and you would just make sure your vertex snap is on, and then you can go in there and you can measure some of these distances. You can go from vertex to say vertex and get an idea of how thick or thin something is. Right there, that looks pretty thin as it goes across there. So some things to be aware of. Okay, so I'm going to go ahead and delete this. So what else can you do? What else can you do with Chromodorus? Well, one thing that I think is really cool is you can draw lines, or you could create lines in Grasshopper, and then you could build isosurfaces from that. Okay, so let's look at doing that. So we made, that was our 3D mesh. We did that from a whole bunch of points. Now we populated the points, we looked at the links. So one thing that I didn't put in here is I didn't put in remove duplicate lines, which is something that that could be helpful. So there's remove duplicate lines. Now, remove duplicate lines, it's actually from Kangaroo. It's a Kangaroo capsule, so you'd have to have Kangaroo installed on your computer or plugged into Grasshopper. So if I go to lines here, so this says 500 and this says 290. So that's a lot fewer lines to deal with. Let's see how it affects my geometry. Okay, so it took some of those lines away. Okay, which changed a little bit of the way the mesh looks. So something to keep in mind. Okay. Alright, what else? That wasn't on the list. Remove duplicate lines wasn't on there. But we did sample voxels, we did build isosurface, we did quick smooth, we did draft angle. Okay, we have a few more things that we're going to do on here, but I want to demonstrate this that you could be able to draw. Okay, you could draw lines and then turn those into isosurfaces. So let's hide all this stuff. Okay, this duplicate lines is still on. Okay, it's a good thing we looked at duplicate lines because we saved ourselves quite a bit of lines there. Alright, so just to demonstrate this, I'm going to draw some lines in Rhino, and I'm going to mix it up a little bit here. Okay, so I'm going to type in line, and I'm going to make a vertical line, and that's going to be from 0, 0, 0, and I'm going to draw that up. Okay, so this is a vertical line. I'm going to draw this up 16 inches. Okay, so there's my line. Okay, so I'm going to start with that, just one simple line. And I'm going to bring that in. And that's something I could make in Grasshopper too. I'm going to bring that in. I'm going to right click and choose Set One Line. Alright, it's looking for the start and the end of that line. Okay, so that was with line. If I use curve, it won't ask me for start and end. So let's do that instead. Okay, if I use curve and I right click and I choose Set One Curve, it just lets me pick the line. I'd rather have that. Okay, and you'll see why, because we're going to make a bunch of lines. Okay, so there's my curve. What we found out above is we needed points, and we'll know that when we choose sample voxels. So if I go to Isosurface and I choose sample voxels, okay, the first thing that it's looking for is points. All right, so we're going to do our divide length. You could use divide curve. There's really no difference. Like if you didn't want to think about the length set between the curves, like for instance, this curve it's 15 inches tall. So let's look at the points. So it is 16 inches tall. So if I put in a length of 1, I'm going to have the 16 points, and it counts the first point. So it counts the 0 point. So 0 through 16 is 17 points. So that's what I'm getting there. Okay, so if I didn't want to calculate distance between, I could certainly just use a divide curve. Okay, and then that has a count. Right now it's set to 10, so I can give that a count. I don't know what that count's going to be, but I'm going to say 12, so it's higher than 10. Okay, I'm going to plug that into points. Okay, so we looked at voxel size and effective range. We can just copy and paste that from above. Take this, put it down here. It's already got our notes. So I'll plug this into voxel size. I'll plug this into effective range. Okay, that lights up. So the voxel data, if I didn't mention it before, it's invisible. We're not seeing, what we don't see is we don't see this. Okay, that we don't see in Grasshopper, unfortunately. So that information is invisible. Okay, so we've got this going on for us. Next thing, that was sample voxels. So our next thing is to build isosurface. So I'm going to plug box into box. I'm going to plug voxel data into voxel data. Then we need our sample value. I'm going to get that from here where we already have it. Okay. Go ahead and plug that in. Okay, so now you see the isosurfaces. So I mentioned that it was like a three-dimensional contour line. I also mentioned that it was sort of like if you put a sphere at every point, and when those start to intersect, they join and they create one mesh. So we're gonna look at that. We're gonna need some smoothing to happen here. Okay, so this changes the size of it. I haven't done, that's not really the smoothing, that's just joining those isosurfaces together to make one isosurface. Okay. We will do some smoothing, so we just need what we did before. We need our quick smooth and we need our draft angle. So let's just take all this stuff, bring it on down. Okay, this stuff has been turned off. I'm going to turn it back on. Okay. So the thinner, or the more smoothing that I make, the more smoothing that I add, I should say, the thinner this line gets. So you can see that it's getting pretty thin in there. That colored area is gotten really thin. That's the smooth part of it. That's this capsule here. Okay, so you're seeing that. So we're gonna make this a little bit thicker. There we go. Alright, so great. It's a line that turned into a bumpy looking mesh. Okay, but what is really cool about this is I can start to draw more lines. So let's look at that. Let's look at doing that. So we have the one, I have the one line here. So I'm going to make a couple circles just to give me some guidelines. So I'm going to make a circle at the very bottom of that. I'm going to make its diameter 12 inches. I'm going to make a circle at the very top, and I'm going to make its diameter 12 inches. Okay, now I'm going to start to draw some lines. So I'm going to draw a line from the quad. Now, it does matter the start and end of the lines. If you were going to do some variations in the thickness, that would certainly matter. So something to think about, knowing where the start and ends of the lines are. So the start of that first vertical line was down here. I'm going to draw from the quad. My midpoint snap is also on, so I'm going to find the mid, and I'm going to draw another line from that, and now I'm going to do it again from the quad in. If I can find that mid. Okay, so now I have some more lines. So I'm going to right click and choose set multiple curves. So I'm going to choose the middle one and this one. Enter. Oh, look at that. They're starting to join together. They're making one mesh out of them. Okay, and I'm going to start to add more of these. So I'm going to go ahead and pick all these. Okay, so you see we have some places on the circle where this is breaking, so we have to work on that. Alright, so let's do that together. Let's take a look at this. Alright, so I'm seeing some data tree stuff happening here, which I mentioned that anything data tree needs to be flattened out. Okay, so I'm going to take this draft angle, and then I'm going to use Shift Control I, and I'm going to right click, and I'm going to turn preview off. Okay, so I just have. Alright, Rita wants to hang out with us. She wants to join us. That's what she's telling us. Either that or it's a squirrel or a dog. Alright, so here we have a data tree. So I'm going to go ahead and I am going to flatten that. Okay, so I'm going to flatten that data tree, and that flattens out all the way through. Okay, so I'm worried about the points on the circle not merging into the other ones. So It's just a matter of getting in here and seeing where I can change that. Okay, so this starts to join. Alright, but then it starts to break. Alright, so let's look at that. We've changed that. Could be a lot of things. There could be the smoothing. That doesn't seem to be really affecting joining those together. Let's go over and look at the range. The effective range. Alright, so that's helping us out here. That's closing that in. Alright. Alright, so let's start to draw some more lines into this. Get this looking a little nicer. Alright, so I'm going to close Grasshopper. I'm going to save it and close it. It doesn't really close, it just, the window goes away. Alright, and I'm going to make some more lines. I'm going to make some three-dimensional lines here. So maybe from the midpoint of this up to the quad of that. Now I was drawing all my other lines from the quad to the point, so I'm gonna do that. So I'm gonna draw from this quad to this point. If I can find the midpoint of that, orbit a little bit. There's the midpoint. Okay. I'm gonna draw from this quad up to the top. So I'm just drawing some random lines. I'm going to draw from this point to this point. Again, I'm going to draw from the quad of the circle instead. Alright. Draw from this point down to that point. Draw from that point down to this point. I'll keep the same. I might as well keep the same order. Alright, so there I have some. I'd like something to go from here down to there. And I want something to go out here. So from this quad, I'll go to here. Alright, so I'm making this structure. I'm kind of looking at it and thinking, well, what do I need to hold up that top circle? You know, connecting back to the bottom circle. So I have something here that looks a little bit structural. Okay, so I'm going to open my Grasshopper back up, and I'm going to go ahead and right click and set multiple curves. Choose all these. Alright. So now we have a structure, and we're going to look at some of our settings. So this is our mesh thickness. The lower the value, the thicker the mesh. We're going to look at our smoothing, okay, because I want to make this a little bit smoother. So here's where I have a hole. I can see a hole there, so that's an issue. So I'm glad we're seeing that. We have a hole in that mesh that's going to create some naked edges here. So I can make sure that make sure that those are getting closed up. Okay, so let's look at our smoothing to try to thin this out a little bit. Okay, so here are my iterations. As I lower the iterations, I get more metaballs or more voxels. Here's my smoothing multiplier, so I can smooth that out. Okay, so what this starts to remind me of is it starts to remind me of all these generative design algorithms that I'm seeing out there. Okay, so if I was to Google search generative design, this is what I'm getting as images, and this has grown quite a bit since last year when I Googled this. You know, so for example, this chair, that's what this Chromodorus reminds me of. The look of it reminds me of something you'd get from the generative design algorithm. So I mean, Grasshopper in its essence is really a generative design tool, especially the way we're using it right now. It's generating form for us. Okay, so I want to keep going with our outline here. Alright, so we saw we could draw lines. Now on our outline we have sample voxels custom, and we have closed voxel data, and then we have the bonus, which is charges. Okay, so let's take a look at that. Okay, so I'm going to go back to our first definition to take a look at this. I'm going to go ahead and copy that and paste it. Okay, so I'm going to turn off our draft angle so we don't see that anymore. I can hide these lines. Okay, so we're going to look at sample voxels custom. So where is our sample voxels? Our sample voxels is right here. So we're going to replace this component, or this capsule. We're going to replace that. Okay. So I'm not going to delete it. I'm going to leave it there as a reminder of what we're replacing. It's just a little easier for us to remember. So I'm going to go here under Isosurface, and I'm going to choose Sample Voxels Custom. Okay, so the difference between that, it has points charges, it says points charges, it has box, and then it has resolution, XYZ. So that's the new voxel size, and then it has an effective range. We didn't look at density sampling or linear sampling. You can take a look at those. Those are true false toggles. You can use Boolean toggle. It's very minor in the way that it edits the form, but you can surely take a look at that. Sometimes you get some results that you want to have there. Okay, so points. I'm going to plug my points in. I'm going to leave charges. We're going to come back to that at the end. Okay, so box. It's looking for a box that's representing the voxel grid. Okay, so this is where you can define how big or small you want the voxel grid to be. Okay, so I'm going to make another center box. Okay, so you see the little box there. I'm going to plug that into box. Okay, size of it. I don't know what the size is going to be, but I want to have some large enough values in my number slider. Copy this. Copy that. Okay. So there's my box. Okay, so now I can define, it's getting a little messy. My apologies for that, but just the way it goes sometimes. Alright, now the XYZ resolution. So we can enter that in. The number of grid cells in the X, the number of grid cells in the Y, the number in the Z. Alright, so I'm going to reuse these number sliders. Okay, those will be editable. Okay, and the last thing that it's looking for is the effective range. So let's take this. Alright, so now we're going to want to see what this does, what the difference is between. Now here we're not going to really see much of a difference, but where we want to see it Okay, so there's the two boxes. So we have the one big box and the one small box. We're not seeing the resolution within it. Okay, I can make the box, I can make this box smaller. I can do this as needed. I do want to pop it up. This box is going below Z, and that one is not. So I do want to pop this up. So I'm going to use a unit Z, like we did at the beginning, and I'm going to plug this in. Okay, so that's popping up at 0. Alright. Okay, so what we're going to need here is we're going to need an extra little capsule. We're going to need closed voxel data. Okay, that's going to get plugged into here. That's going to go into our voxel data. And our box is going to go into our box. Okay, so this closes the voxel data. We'll see in a bit why we need to close that. Alright, so you see, because it starts to separate itself. Alright, we're going to need to close that. Everything else is fine. Okay, so all we've done is switched out the sample voxels for sample voxels custom. Okay, so let's kind of play around with this. It's pretty cool. Let's turn on this. I'm going to turn off all this new stuff. Okay, so let's see how we can affect this. Now this changes, so it's going to be contained within the box. Okay, so this is the box that it's using to contain the geometry inside of. Okay, so as I lower this down, as I lower that Z, it's only 3 units tall. But if I raise that up, as long as it's past the height of all the points, okay, as this gets smaller, it cuts it in the Y direction, and then this cuts it in the X direction. So this is defining the size of that box. Okay, so that's custom, and you're getting some interesting things happening that are thin at the very bottom there. So then you also have the resolution that you can play around with. So you're seeing that happen in the X and in the Y and in the Z. So more voxels the higher this is. Alright, so you're getting something a little bit more customized. You have a little bit more flexibility there. There's a lot of number sliders, a lot of things to kind of mess around with in terms of flexibility. Okay, alright, let's keep moving here. We've covered a lot. The last thing that we want to cover is charges. Okay, so this one is the number slider that we've been seeing in the sample voxels. We've been seeing charges, and we also saw it in the custom. We see the charges there as well. Okay, so I think the best way that I can do this is with the single line to show you how the charges work. Okay, so let's go back to that. So I can hide all of this stuff. And turn back on this middle section here. You know what I haven't been using lately? I don't know why. Sometimes I use things like all the time, and then I don't know, I get bored of them or I forget about them. But we organized this definition. It's not horrible. It's not great, but it's not horrible. What I haven't been using is my little not so straight line tool. So I can draw not so straight lines, and okay. Alright, so let's see what we can do with this to best show the charges. I wasn't in love with the charges. I don't think it works fantastically, but we're going to take a look at it. Alright, so I'm going to go to this curve one, and I'm going to choose set one curve, and I'm going to pick my, oh, I have those hidden. So I have to show these curves. So I'm going to go back to set one curve, and I'm going to pick that vertical line. Let's try it again. We'll get it. Set one curve. There it is. Okay. So we're going to vary the thickness of the mesh. That's what we're going to do with the charge. Again, I wasn't in love with it. It works well with a single line to explain it, but it didn't work great with multiple lines. Okay. But that's what we're doing. We're exploring. So let's explore it. Just want to clean this up. It's not going to work. Okay. Alright, let's look at this charges. So that's there. So what I'm going to do is I'm going to get some values. And I'm going to take a distance from, I'll start with the bottom point. I can always try something from the middle point. So I am going to add a point. I'm going to add this in Rhino. I'm going to put this at the very bottom. I'm going to bring it in. Okay, I'm going to right click and choose set one point. Pick that point. It's in there somewhere. Okay. So it's just a point at the very bottom. And I'm going to use a distance. It's kind of like a little attractor, maybe definition. Maybe not. But yeah, like an attractor. Okay, so from distances not to, I'm going to make, it doesn't really matter, but I'm going to make this bottom of it, I'm going to make that to point B, and then distance to all of the other ones. You know what? Let's keep it a little better organized there. Okay, so I get a bunch of distances. Okay. So I could plug this into the charges and see what happens. Alright, something's happening there. It's breaking. But let's keep going with this, because the values, the distance values coming out of here are pretty large. They're from 0. You can, if I can't point to it, but they're from 0 to 16 right now. So if I want those values to be smaller, I have to remap it. So let's unplug. So if you're fairly new to Grasshopper, you're learning a lot of different things here, which is always good. So we're going to remap the values. So I'm going to type in remap numbers. Okay, the value is going to be the distance that's coming out of here. And there's one for each point. So there's 13 of those. Remember, count 0, so it's 12 plus one more. Okay, the source domain. Source domain. So I need to find that. I need a bounds capsule. Oh, we're getting messy now. It's good that we're at the end. We're close to the end because we're getting messy. Alright, my little line that I drew. Okay. Alright, so remapping. That's the source bound. So that's going to be from 0 to 13, I think, is what we saw, or 0 to 16. Okay. Yeah, there we go. 0 to 16. 0 to 16, that's the domain. That's the domain. 0 to 16, we could see that right there. Plug that into source. So what do we want our target domain to be? I don't know. So I'm going to make a construct domain. Okay. I don't really know what I want these start and end values to be, but I can make some number sliders that I can use those as fall off values. So let's see, point 0.0333, and it's probably a little small, 0.333. Let's try that. And then the domain end, I'm going to try get some higher values in there, 2.000. Okay, so now my map numbers coming out are between 0 and 2. They were between 0 and 16. Now they're between, not quite 0, they're between 0.333 and 2. So just remap those values. I'm going to plug those into the charges. Okay. So what I like about this is we're getting smaller values at the bottom and larger values at the top. But it's broken, so we did label the one number slider until it breaks. So let's look at that. And then probably less smoothing on this. I don't want to go to 0. I do want to make sure that I'm getting something at the bottom. So it's probably going back. I want this pretty smooth like that. So it's probably going back to my domain. And working with this a little bit. So making this larger, it looks like. Okay, how about this value? Oh, it breaks at some point. Okay, so we're looking at the charge. We're varying, and again, I told you I wasn't in love with it, but we're varying the thickness of those members. So that's why I was telling us to be conscious of where we're starting to draw from. If I was starting to draw from the quad down, that should get thinner at the beginning. So let's just test it out here. So if I go to my curve and I set multiple curves, I want the middle curve and this one. Not loving that because I don't really see that one getting much thinner in the beginning of it. Let's try another one. Let's try it out. Right click, set one curve. Okay, that one's working a little bit. Right click, set one curve. Or not set one curve, let's set multiple curves. Set multiple curves, we'll pick this one and we'll pick this one. Okay. So some variation there, but they start to merge together, so the charges don't always work really well when you have a lot of objects. Okay, let's see what it looks like when I set the whole thing. I'm just going to go for it. Set multiple curves. Alright, getting that to break at that very bottom one. Let's see what we're going to do. Let's go back to our one where we break it. Okay. Of course, I'm not going to be successful with this one. It is thinner at the bottom, so that we are achieving some thinness at the bottom with the charges. Just got to get it to fill in. Let's go for it. Let's see what happens. In a way, it kind of makes sense because we're making it thinner from the very bottom. Oh, it's so close. So close. It's just that top part of it. It looks pretty interesting too. Let's see what we can do with the charges and see if that helps. It's like when I get that bottom one to fill in, I can't get the top one to fill in. Alright, well. Do I give it some more? Told you I didn't like the charges when it gets applied to more than one object. Oh! Almost. Almost. That's so close. That's so close. I guess ending with crashing Grasshopper would be fun. Oh. Oh, I just didn't want to give up. Well, it's not beautiful, but it's closed. Is it closed? Come on, let's end with the big surprise if it's closed or not. For those of you that are still with me. Alright, let's bake it. Save it. Oh, look at that. Look at that. We got an extremely short edge and we got 3 pairs of faces that intersect each other, but we don't have any naked edges. This is the disjoint pieces, so it's just a matter of exploding this, hiding the big one, selecting the mesh, deleting it. Let me show that again. Let me check it again. Okay, and look at that. That's a good mesh. It's because it was disjoint before that we had some issues. So it's good. It checks on all different levels there. Alright, pretty exciting. So that's Chromodorus. If you enjoyed this video, you're going to see my head pop up. Go ahead and subscribe. I guess you should subscribe anyway, whether you enjoyed it or not. But if you enjoyed it, give me a thumbs up. Let me know why you enjoyed it. My head's going to pop up. Click on that to subscribe. I'm going to put some links in the upper right to some other videos. Look out for some more mesh subdivision, mesh pattern generation videos coming soon. Alright, I will see you on the next one.